Heading is the inequalities. Inequalities, right? Okay. Right. Here, first of all, we must understand people this thing. Now, when we consider the number line, is the number line, right? On the midway of the number line at the midpoint, we have the real number 0. When we go to the right of this 0, on the right of 0, we have these page numbers now, people. 1, 2, 3, 4, and so on. This goes to infinity. So we put this arrow to say, actually, we put that arrow to say we can't see an end to that end. Okay. Okay. Now, wherever this line ends, at that ending point only this plus infinity lies. Since people now, when we extend this line to this direction, nobody can find what an end. Therefore, nobody can find the exact position of plus infinity on this number line. And on the right of 0, all these real numbers are people positive. And to the left of 0, when we consider, to the left of 0, we have values like this: -1, -2, -3, -4, and this way this goes to negative infinity. And negative infinity is the place on the number line. Now this left end, where does this left end end? At that end, we have the negative infinity, and we can't find such end in the left hand side of this number line. So therefore, negative infinity also, people, nobody can locate on the number line. So therefore, this negative infinity and positive infinity both, right, do not lie on the number line. So therefore, the negative infinity and positive infinity are called as not real numbers. They are not real numbers. They are imaginary. They are imaginary. Actually, in other words, such values in real life nobody can find. Not real. Not real. And therefore, they are not available on the number line, and therefore minus infinity and plus infinity are not real numbers. Right. Now, when we consider on the right hand side of 0, all the real numbers are positive. On the left hand side of 0, all the real numbers are negative. And the other thing is, when we consider any two consecutive real numbers, or in other words, suppose we take any two real numbers on the number line. I take here this real number and this real number. The real number which is on the right is always greater than the real number which is on the left. That means when we consider any two real numbers on the number line, the real number which is on, so it's very obvious when we consider the real number, this 4 and this 1, 4 is on the right of this one, then 4 greater than 1. And we consider here, people, say minus 3 and minus 1, minus 3 and minus 1, which is on the right, people. Minus 1 is on the right. Therefore, it is greater than this minus 3. Minus 1 greater than minus 3. Okay. Okay. Now, when we consider any real number on the right of 0, suppose that real number is x. Because when we consider on the real number line, there are infinitely many real numbers. Between 1 and 2, when we consider number of real numbers between 1 and 2, again there are infinity. Again there are infinity. Right? Yeah, now when I consider real numbers between 1 and 2, between 1 and 2, there are infinitely many real numbers. 1 and 2, I am saying. For example, if I consider this 1.01 on the right of 0, left of 2, 1.001 also same way. 1.1 between 1 and 2, 1.11 between 1 and 2, 1.121 between 1 and 2. People like this, how many real numbers we can write? Infinite we can write. Therefore, between the real numbers 1 and 2, there are again another infinitely many real numbers. Infinitely many real numbers. Okay, right. Now I am going to consider any real number. It is x, which is on the right of 0, which is on the right of 0. Right now, when we consider this 0 and this x, obviously this x is positive. Why, people? The x lies on the right of 0. X is positive. That is lying on the right of 0. Now, when we consider this 0 and x, since this x is on the right of this 0, x greater than 0. X greater than 0. Therefore, the x is positive is written as x greater than 0. So therefore, if we need to say something is positive, it can be said as that thing is greater than 0. Similarly, when I consider people on the left of this 0, another real number, suppose it is y. Since this y is on the left of 0, y is negative. Y is negative. When we consider this y and 0, since this 0 is on the right, when we write y and 0 like this, since the 0 is on the right of y, every occasion the number which is on the right greater. Then we can write 0 greater than y. Or in other words, y less than 0. So therefore, if any real number is negative, to say that we can write y less than 0. Y less than 0. Understood, people? Right. Okay, now this way, if something is negative, we write that is less than 0. Okay. Right. Now, the other thing is this. Right. Up to here, I think you can clearly understand. Right. These are some fundamental things, people. These are some fundamental things. You know sometimes this, not sometimes. You know these things. Right. Now, the other thing is this. Now, suppose when we consider two real numbers, right? I take a greater than b. A and b are two real numbers. Now, for example, here I take as my a 4, as my b I take this 1. Then it is true that 4 greater than 1. This is true. When a greater than b, people, in this case, if we subtract b, the right hand side 1, when you subtract from the left hand side, a minus b, a must be different, also positive. See here, 4 greater than 1, then subtracting this 1 from 4, 4 minus 1. What is this? This is, people, 3. 3 means 3 greater than 0. Right? If a greater than b, then a minus b is positive. And the other thing is, when we consider two positive real numbers, A positive, B positive. I'll take as our A4 as our B1. Now I am going to add A and B. See what we get. 4 plus 1. 4 plus 1 is 5. 5 is positive. That means what people? When we add two positive real numbers, the answer is positive. And when we have two positive real numbers like this, the product also positive. A positive, B positive. 4 multiplied by 1 is 4. 4 is positive. Right? And the other thing is, A less than B. I take 3 less than 4. That's true, no? Then subtracting this B from A. What is that? A minus B. See here, 3 minus 4. People, 3 minus 4 is what? Minus 1. This minus 1 is less than 0. That means A less than B, then A minus B is negative. That means if A less than B, A minus B is negative. A minus B is negative. A minus B is negative. Right? Now, when we consider two real numbers, one is positive, other one is negative. 4 is positive, minus 2 is negative. Then in this case, people, when I multiply 4 and minus 2, it is minus 8, no? Minus 8 is a negative value. So therefore, 4 multiplied by minus 2 less than 6. That means if A is positive, B is negative, then A, B product is negative. Right? A is positive, B is negative. Then AB product is people negative. AB product is negative. Understood? AB product is negative. Right. So these are the things, people, that we must first understand in the lesson. Right. Now we'll take down this one. These are fundamental things. Based on this fundamental, we have some theorems. We have some theorems, right? Under this inequality, they are called as fundamental theorems in inequality. We will discuss them and we'll prove them. Thereafter, we can go to the question straight away. Okay. Right. People, then will take down notes. I think at the moment, write down a subheading there as real number line. Real number line. Right. I've been write down real number line. Right. We'll draw the real number line. This is the real number line. Exactly midway, midpoint of the number line, we have 0. Right. This is called as the real number line. Right. On the right of 0, we have positive real numbers. On the left of 0, we have negative real numbers. Negative real numbers on the left of 0, right? Right. First draw this one, people, and you write the small note. Okay. Now we'll write like this, people. on the real number line, on the real number line, on the real number line, all the real numbers, all the real numbers which are on the right of, which are on the right of 0, which are on the right of 0 are positive, are positive, and all the real numbers, all the real numbers which are on the left of 0, which are on the left of 0 are negative. The real number line terminates at plus infinity, at plus infinity on the right and at minus infinity on the left. But it is not possible, but it is not possible but it is not possible to find these points. Therefore, the plus infinity and minus infinity plus infinity and minus infinity are not considered as real numbers. Real numbers. Right now, next one. Right, start from new line. When we consider any two real numbers, on the real number line, on the real number line, on the real number line, the real number the real number which is on the right, is greater than which is on the left. Which is on the left. Suppose we have x here, y here. Then x greater than y. Right, people. Draw the small one. X is on the right, y on the left, x greater than y. Okay, draw this one and write this. Next one, write down. Let x be a positive real number. Positive real number. Let x be a positive real number. Since this x is on the right, since this x is on the right of 0, since this x is on the right of 0, we can write x greater than 0. We can write x greater than 0. Therefore, people, if x is positive, that we can write as x greater than 0. Understood? Right. Next one we'll write, put another square mark. Let simple y be a negative real number. Since y is on the left of 0. Since y is on the left of 0, we can write y less than 0. Y less than 0. Okay. Right. Now we'll write fundamental properties. Fundamental properties. Fundamental properties. Right, fundamental properties, people. First one, if A positive and B positive. If A positive and B positive. Both A and B are positive. Therefore, what is the sum, people? Therefore, A plus B, the sum is positive. What can you say about the product of A and B? AB product also positive, no? Take A as 4, B as 10, 4 plus 10 is 14. Sum is positive. Multiply 4 and 10, 40. 40 also positive. So therefore, the first one is this. If A positive and B positive, A plus B positive, and AB product also positive. Right, number 2. If A negative and B negative. If A negative and B negative. Huh? Then what can say about A plus B? Suppose A is -2, B is -4. These two we add. The -2 -4 is -6. Then what is the sum? Sum also negative. A negative and B negative. Then A plus B, the sum is negative. And what can say about AB product? AB product is positive, right? AB product is positive, correct? No? -2 -4 when you multiply. A negative, B negative, both are negative. Then when we multiply these two negative figures, the answer is positive. We know that. Correct? No? Both are negative. A and B both are negative. People, next one, number 3. If A positive and B negative, then what can say about the sum? Right, the sign of the sum cannot be said definitely. That depends on the values of A and B. Now, for example, A positive suppose 10, B negative suppose -2. Then 10 plus -2. What is this? 8. Answer is positive. Suppose A is 10, B is -12. Then 10 plus -12. What is this? -2. Answer is negative. So that's why I said if A positive and B negative, then nobody can say the sign of A plus B. But obviously we can say AB product, A positive, B negative. That means plus and minus signs when you multiply together, answer is negative. Then AB product is negative, right? If A positive and B negative, then AB product is negative. A plus B, the sum we can't say. Here also we have tried, then and this. And this, AB negative. Fourth one, people will take. Fourth one, if A greater than B, if A greater than B, A greater than B means A minus B positive. That means B is smaller than A. A smaller thing is subtracted from bigger one. Then the difference is positive. So therefore, if A greater than B says, we put this way the arrow. A greater than B gives us what? A minus B. Positive. And A minus B positive gives in the backward direction for A minus B difference to be positive. Definitely this A should be greater than B, no? So therefore this implied by this way. So therefore people, you know, you are familiar with this notation. We use this notation at the first time in our mathematical works in quadratic equation lesson. At the end of the lesson, we did some past paper sums. To prove they are the if and only if proof, we use this. This is saying what? If A greater than B, then A minus B positive. That is by this arrow. Then secondly, if A minus B positive by this arrow, that implies A greater than B. Right? Both directions we can use that. Okay. And the other one also people true. Number 5. If A smaller than B, A smaller than B, then what is A minus B? Smaller value minus greater value. The difference will be negative. Like 4 minus 10. Minus 6, no. then the answer is negative. Negative means less than 0. Then you can write this implies a minus b less than 0 and implies y. This way, a minus b negative. Right. Now we'll come to people. Some fundamental theorems. These theorems, of course, without proof we can understand. But people, I'll prove that one because that will be very helpful as a math student, how to just prove them. They are well obvious things. Some well obvious things, people, we can prove, not all. Right? Yeah. So we'll discuss that theorem. Right. Write down subheading as fundamental theorems. Fundamental theorems. Fundamental theorems. Okay. Fundamental theorems is the next subheading. Fundamental theorems. Right. First one is this, people. If A greater than B and B greater than C, then A greater than C. A greater than C. This is theorem. Even this is very non thing. Now I take this here. 10 greater than 8, no. 8 greater than 6. That's also true, no. This is true. This is also true, no. Then this fundamental theorem says this thing and this last one, 6, when we consider 10 greater than 6. This kind of thing only, this fundamental theorem states A greater than B, B greater than C, then A greater than C. A this one, C this one, A greater than C. Here, 10 greater than 8, 8 greater than 6. Then 10 greater than 6. This is well known thing. This is well known thing. Well known thing means anybody agree with this. That is called as obvious. This is well obvious. Obvious, right? But because this can be proved in mathematics, we can prove this. Now, this is very simple thing. No? Can you prove this now? Can you prove this now? Now, see, very simple thing. Well obvious. Everybody agree. And sometimes you might say, no, there is nothing to prove. It's well obvious. It is, everybody knows this. That's true, people. I am also agree with you. But mathematically, according to mathematical principles and mathematical knowledge, using the behavior of the mathematics, we should be able to prove this one. Now I am asking that how to prove this. Now, people, now we can prove this very easily like this. Proof. Now we are given A greater than B, no? People, A greater than B implies what? Subtracting B from this A minus B positive. A minus B positive. We'll take this as number 1. Next one, b greater than c implies, since b greater than c, subtracting this c from b, we get b minus c. No? Since c smaller than b or b greater than c, b minus c also positive. This is number 2. Right. Now people, you can see this a minus b, right? Positive value, no? This b minus c also positive value, no? Then we said when we add two positive values, the answer is again positive. We said that. Huh? We said it, no? A positive, b positive. Then a plus b is positive. We said that. Like that, this is a positive. This difference is a single real number. Like now, suppose a is 10, b is 8, 10 minus 8, 2. Single answer coming for this. That is positive. Like that. This is single answer. Single value, this has b minus c. That's also positive. Then we have two positive values. Then the sum of two positive values is again positive. Then we can say by 1 and 2, a minus b is a positive value. To that, I add this b minus c. That's also positive. This is positive, this is positive, their sum is positive. Therefore, this one we can write as greater than 0. Then we can simplify here, a minus b plus b minus c greater than 0. This and this we can cancel down. Okay. Then what do you get? A minus c greater than 0. For a minus c difference to be greater than 0, definitely subtracting this c from this a, the difference to be positive, you know what, people? A should be greater than 0. This implies what? A greater than 0. This is how we prove. See the obvious fact and the proof. In the proof, we have used some mathematical properties, fundamental properties. Using them, we have proved. Right? Okay. These are very simple things. Right. Second one, people. Second fundamental theorem. Number 2. Number 2 is this. Then, number 1, a plus c greater than b plus c. Number 2, a minus c greater than b minus c. This is the second theorem. If a greater than b, a plus c greater than b plus c, a minus c greater than b minus c. People, what do you understand by these two results? We have this a greater than b. I'll take for a 10, b 8, then 10 greater than 8. Then this number 1 says, when we have this way an inequality, to both sides, we can add the same value. Even after adding the same value, still the same direction become true. That's what this number 1 says here. For this a greater than b, c added to both sides. To this side and this side, this c added. Now here I can add 2 to both sides. Now what do you get? 12 here, right hand side 10. 12 greater than 10. That's what this number 1 says. Number 2 says 10 greater than 8, we subtract the same value from both sides. Same value we subtract from both sides. Even after subtracting the same value from both sides, still the direction of the inequality sign becomes true. Yeah, so then see here, 10 greater than 8, I subtract 2 from both sides. 8 minus 2, 8 minus 2. This is people 8, this is 6. Still 8 greater than 6. This direction become true even after subtracting. So that's what this says. So that means people, from both sides of an inequality, the same value we can subtract. Still the direction of the inequal sign, same direction. Right. That is the property. Right. So then how to prove this, people? How to prove? The proof is done like this. Proof. Number 1. We take first this a plus c minus b plus c. I take this a plus c minus b plus c. I simplify this. See what you get. A plus c, remove the bracket, minus b minus c. Plus c and this minus c you can cancel out. Then we get a minus b. Here a plus c minus b plus c. I think you can agree. Right. Because now we are given a greater than b, no? Given that a greater than b. Because a greater than b, this implies what? Here we are given that, no? A greater than b. A greater than b gives us what? Subtracting b from a, the difference is positive, no? Why? Because a greater than b. This implies a minus b positive. A minus b positive. Right. But here we have a minus b. This is positive. Right? This is positive. If this is positive, since this is equal to this left-hand side, this difference should be positive. Left-hand side, this difference should be positive. Therefore, you can write, therefore, this a minus b is this. It is a plus c minus b plus c. Positive. This a plus c is a single real number. It's like a is 10, c is 2, 10 plus 2, 12. No single real number coming for the sum of a plus c. This is a real number. This is also real number. This real number minus this real number. That difference is positive. For this to occur, people, definitely this a plus c real number should be greater than this b plus c. So therefore, this implies a plus c greater than b plus c. See here the way of proving this. This is how we prove. This is how we prove. Right. Second one. In the same way, you can prove the second one. Prove the second one, people. Second one, to prove the second one, we can take this way, number 2 proof. I'll take a minus c. From this, we subtract b minus c. And we simplify this. A minus c, remove the bracket by multiply minus sign, minus b plus c. This two you can cancel now. This a minus b. Right. Given that a greater than b, given that a greater than b, this implies what, people? A greater than b implies a minus b is positive. But a minus b is equal to this. So therefore, for this place of a minus b, I can put this. A minus C. That says, people, for this difference to be positive, definitely this number should be bigger than this number. Then this implies what? This implies what? A minus C greater than B minus C. See here, this is how we prove. This is how we prove that. Right. I will write the third one, people. Number 3. Third one. Third one is this. If A greater than B and C greater than 0. C greater than 0 means, people, C positive. C greater than 0 means C positive. Then we can write two things. Then number 1, AC greater than BC. Number 2, A divided by C greater than B divided by C. Okay. What is this result, people? What is this result? This result says, now suppose this way we have 6 greater than 2. You agree with me? When we have this way an inequality, the left hand side and right hand side, both sides, you can multiply by a positive value. After multiplying by that, still this direction becomes true. Now I multiply this both sides by 2. 2 is a positive value. So what do you get? 12. Right hand side 4. Still the left hand side greater than right. That is the first one. Second one, people, same way, both sides we can divide by a positive value. We can divide by a positive value. Still the same direction becomes true. So now here 6 greater than 2. When I divide both sides by 2, left hand side 3, right hand side 1. Still 3 greater than 1. The same direction becomes true. Right. Now see, people, how to prove this. How to prove. Proof. Number 1. Right? Number 1. First one, A greater than B. This is given. This is given. If A greater than B, this implies what, people? A minus B is positive. Then A minus B is positive value. Since C greater than 0, C given as positive value. Now this A minus B is a single number, it is positive. C also another single number, also positive. Then this is positive, this is positive. You know, people, when we multiply two positive values, the answer is another positive value. Therefore, we can write A minus B and C. We multiply. Product of two positive real numbers is, people, positive. So therefore, this should be positive. Okay. Now I can remove the bracket. A into C minus B into C greater than 0. Now AC minus BC difference positive. For this difference to be positive, definitely this AC should be greater than BC, no? So therefore this implies This implies people AC greater than BC. That means the first result, this is coming. Similarly, we can put the second result too. Right, welcome to second result. Second result number 2. Right. Even now, when I consider 10, when we write 10 like this, people, this is really 10 divided by 1. No. This is positive value. Right. Then the reciprocal of this 10, reciprocal, you know, reciprocal of 10 means 10 is 10 divided by 1. No. Reciprocal means we exchange this 1 upon 10. It's a reciprocal. If this number is positive, its reciprocal also positive, people. Its reciprocal also positive. So therefore, you can say this way: A greater than B. This is given. This implies A minus B positive. That is okay. You agree? Since C greater than 0, its reciprocal 1 upon C also positive. Correct, no? C is positive. C is like 10. 10 positive, no? So then reciprocal of 10 means 1 upon 10. Then reciprocal of C is 1 upon C. 1 upon C is positive. Now, this 1 upon C is a positive value. A minus B, positive value. This is positive, this is positive. When you multiply two positive values, people ask it again positive. Therefore, you can write, therefore, A minus B into 1 upon C greater than C. Okay. Now you can multiply this. A into this. A into 1 is A by C minus B into 1 by C. Positive. You know, this difference become positive means people, this A by C should be greater than this B by C. Right? This implies what? A by C greater than B by C. This is how we do the second result. This is how we do the next result, right? Right. Now, the next one, people, they say, number 4. Number 4, people, right? Fourth one. Fourth one. If A greater than C and C less than 0, C less than 0, C negative. Now, C is something like this: 10 greater than 8. I multiply both sides by minus 2. What do you get to left hand side? Minus 20. Right hand side minus 16. Out of these two people, which is bigger? Bigger is this now. What do you understand by this? This way, when we have an inequality, and if we multiply both sides by minus value, what happens to this inequality? The direction gets opposite. This direction gets opposite. That's what I will say. Again, when I divide both sides by minus 2. Then 10 divided by minus 2 is this how we write now. 8 divided by minus 2. Then plus by minus is minus 10 divided by 2 is 5. Here minus 4. Now what is bigger, people? Now minus 4 is bigger than minus 5. What do you understand by that, people? When we multiply or divide the both sides of an inequality by a negative value, then what happens? The direction of the sign gets opposite. The direction of the sign gets opposite. That's what this result says. Right? So then what can we say here? Then we can write the first one. Number 1, AC smaller than BC. AC smaller than BC. Number 2, A divided by C smaller than B divided by C. If A greater than B and C less than 0, C negative. This way we can write the two results. Right? Write down the next theorem. Next theorem is this. And how to prove this, people? That proof. Number 1, A greater than B is given. This implies A minus B greater than 0. Since C less than 0, if C is negative, A minus B is positive. When we multiply this A minus B with this C, this is positive, this is negative. When we multiply positive and negative values, the answer is negative. Since C less than 0, A minus B multiplied by C. This is positive value, this is negative value. Positive multiplied by negative, product is negative. Then remove the bracket. AC minus BC, negative. People, AC minus BC to be negative, when you subtract this BC from this AC, the difference is negative. For these people, definitely this AC should be smaller than this BC. When you take negative answer after subtracting, when we subtract bigger value from smaller value on the paper, we get negative answer. Therefore, this implies what? This implies AC smaller than BC. This is how we do the next one. Is okay. And proof of the second part. Proof of the second part. Okay. Right? Yeah. You know this. A greater than B given. This says what, people? A minus B positive. Next one. Since C less than 0. Right, people, now suppose we have minus 10. Minus 10 means really what? Minus 10 divided by 1. If we find the reciprocal of this, what is reciprocal? 1 goes to numerator, this minus and 10 come into denominator. Then here we have plus, this is minus, then this is minus. Minus 1 upon 10. So what can we say? If we have a negative real number And if we take its reciprocal, that's also negative. That's what this says. Okay. Since c less than 0, c negative, then 1 upon c also negative. Now this 1 upon c negative, a minus b positive. What if we multiply this a minus b with this 1 upon c? Positive value multiplied by negative value. The product is negative, no? Right. So then this gives us, therefore, a minus b multiplied by 1 upon c. The product should be negative because when you multiply positive value and negative value, positive value and negative value, the answer is negative. Now remove the bracket. A times 1 upon c. That means a divided by c minus b divided by c less than 0. For this difference to be negative, definitely this a by c should be smaller than this b by c. So this implies because a by c less than b by c. This is how we prove that result. Okay, right. Prove that people. Right. Number 5, the next. Right, fifth one, next one. Number 5. Right. This is the number 5. If a greater than b greater than 0. A and b are positive values with a greater than b. For this, we can take a simple example like this here. 100 greater than 10. Both are positive values, right? People, this 100 means 100 by 1, no? 10 means 10 by 1. Now I take the reciprocal on both sides. I take the reciprocal on both sides. Left hand side reciprocal going to be people 1 upon 100. Right hand side it is 1 upon 10. 1 upon 100 means what? 0.01. 1 upon 10 means 0.1. Now out of these two, what is bigger? 0.1 is bigger. If this is bigger, this is bigger. What do you understand by this, people? If we have two positive real numbers which relate by this 100 positive, 10 positive, 100 greater than 10. When you take reciprocal, the direction gets other way opposite. That's what it says. When we have two positive real numbers related by particular inequality, then once you take the reciprocal, the direction of the input sign gets opposite. That's what it says. Therefore, if a greater than b greater than 0, both should be positive, people, to write this result. Right. Then what can you say? Then 1 upon a less than 1 upon b. So this is that result. Okay. Right. Let's see how to prove this. Let's see how to prove this. Right. Now, this one we can prove it is like this. Right. True. A greater than 0, B greater than 0. Right? A and B both are positive. Then what can say about AB? Therefore, AB product also positive. AB product positive. Correct? No? A and B both are positive, then that means product of two positive values is positive. Right? That is true. If AB is positive, this implies 1 upon AB also positive. Why? The reciprocal of positive real number. The reciprocal of positive real number is positive. Right? 10 is positive. Reciprocal of 10 means 1 upon 10. Also positive. Like that. If AB is positive, AB product is positive, 1 upon AB positive. Right. Now, we are given A greater than B. This is given. If A greater than B, this implies what, people? A minus B greater than 0, positive. You know that too. Now this A minus B is positive value. 1 upon AB, positive value. Then what can you say when we multiply this 1 upon AB with this A minus B? Since both are positive, the product is positive. Then you can write 1 upon AB multiplied by A minus B. Positive. A minus B is positive. 1 upon AB positive. Product of two positive values is positive. This way. I will remove the bracket. What is that? 1 upon AB into A minus 1 upon AB into B greater than 0. Now, this A and this you can cancel down. This B and this B you can cancel down. What do you get? 1 upon B minus 1 upon A positive. 1 upon B minus 1 upon A positive means, people, this difference is positive. That is what? 1 upon B should be greater than 1 upon A. This implies what? 1 upon B greater than 1 upon A. This means what? 1 upon A smaller than 1 upon B. This implies that required result. 1 upon A smaller than 1 upon B. This is how we prove that result. Okay, try that. You know, yeah. Now, the two more people on the theorems, then we can come to the questions. Number 6. Right, it is this people. A, if A greater than B and C greater than B, then A plus C greater than B plus D. What is this result? When I write the first result a greater than b, like this, and below this when I write c greater than d, these two inequalities we can add. Before adding, the direction of the sign points the same direction here, greater than, greater on the left, small on the right. Once you add this, left hand side what do you get? A plus c. Right hand side what do you get? B plus c. Put the same direction. That's what this. Okay, what do you understand by this result? That result says when we have this way, here we have two inequalities. In these two inequalities, the directions arranged to the same of the inequality sign. After arranging the inequality sign to the same direction, the left hand side and the right hand side you can add. Still the same direction become valid of the inequality sign. That's what this says. Now, for example, people, we know 10 greater than 8, no? 6 greater than 5. At this left hand side 16, at the right hand side 13. Still this left hand side greater than right hand side, this direction become valid. That's what this says. And how to prove this, people? Right. Proof can be done like this. Okay. Proof. A greater than B. This implies what, people? A minus B positive. And C greater than D implies what, people? C minus D positive. A minus B is a real number, it is positive. C minus D also real number, it is positive. When you add two positive real numbers, people, answer is again positive. Answer is again positive. What is that? Therefore, A minus B is a positive value, C minus D also a positive value. Therefore, A minus B plus C minus D positive. Now remove the brackets. A minus B plus C minus D positive. I take this A and C together like this. From this B, it contains minus sign. No? Here this B contains minus sign. This minus sign I take out. Once I take that minus sign out, within bracket we get B plus B greater than 0. Okay. Now A plus C minus B plus D greater than 0 mean this difference positive. For this difference to be positive, definitely this number should be greater than this number. Then this implies what, people? This implies A plus C greater than B plus C. Right. This is how we do that result. That is number 6. Right. The last one, last theory. Right, now number 7 people this. Number 7 says this. 7th one. A greater than B greater than 0 and C greater than D greater than 0. Then we can write AC greater than BD. AC greater than BD. AC greater than BD. People, what is this result? This result you can very easily understand this way. If I write this 10 greater than 2, both are positive, and this 10 greater than 2 is true. Other one, 4 greater than 3, both are positive. Then this result says, in these two inequality, we can multiply them. The left hand side we multiply separately, right hand side we multiply separately. 10 into 4, 2 into 3. This is 40, this is 6. Still, the left hand side number greater than the right hand side. That means the same direction is still valid, even after multiplying. That's what this says. Even how to prove this? Now, all 6 I proved. I'll give you 2 minutes. Just try to prove this one. Right? Prove this. Right. This is how we prove this, people. Proof. A greater than B. Right. Here C is a positive value, no? C greater than D, D greater than 0. That means C and D both are positive. Then I can multiply by C, both sides of this. Since that C is positive, the same direction become valid after multiplying. I'm multiplying by C. C is positive, no? When you multiply by positive value, the direction won't change of the inequal sign, right? Then there we get AC greater than BC. Take this as number 1. Secondly, here, look at that. C greater than D, no? It's also given. Both sides of this I multiplied by B. B is positive here. Then when you multiply this both sides by this B, since B positive, after multiplying the same direction, this become valid. Okay, that says BC greater than BD, number 2. Now this by 1 and 2 people we can take this answer. Can remember we proved something like this. A greater than B, B greater than C. We proved like this. There we said what? This A greater than C. We said this. Like that, similar result we have here. AC greater than BC. This BC, this says greater than BD. AC greater than this BC. It's like this. This thing again greater than C. That means this. BC greater than another one. Then this 1 and 2 you can say what? AC should be what? Greater than BD. Is it clear? Correct, no? AC bigger than this. This is smaller than BC. Now this one smaller than BC. Therefore, if I put this BD here, still this AC greater than BD coming. Then by 1 and 2, we can say, by 1 and 2, we can say, people, AC greater than BD. This is how we do that result. Okay. Okay. Now, that's all the theorems. Now we'll see how to use these theorems to solve some inequality questions, right? Yeah. Right. Right. First one, people, this find the range of x of the following. First one, 3x minus 3 greater than x plus 7. Asking to find what the x. Right. People, first I am going to explain how to use the theorem so far we have learned. First I am going to use theorem one by one. Thereafter I will tell you the short way of getting this answer without following those theorems. Once you follow those theorems, people, the simplification will be very long. Right. Okay. Now we need to find this x, no? Yeah. And then we have to bring this x terms to one side. This is what I do. I subtract x from both sides. That's possible, no? We said from both sides of an inequality, we can subtract the same thing. The direction of the unequal sign won't change. And then due to that, what I get is this 3x minus 3 minus 6 greater than x plus 7 minus 6. This way I get. Then this x minus 6 we can cancel now. 3x minus 6 is 2x minus 3 greater than 7. Then I add 3 to both sides. Then what do you get? 2x minus 3 plus 3 greater than 7 plus 3. That also we put the same value we can add to both sides of an inequality. The direction won't change. Then this minus 3 and this 3 we can cancel down. We get 2x greater than 7 plus 3 is 10. Now we need to find x, no? We divide by 2. We divide by plus 2. That also we proved. Both sides of an inequality we divide by the same positive value. The direction won't change. But if we divide by negative value, the direction gets opposite of the inequality sign. Now here this 2 is positive. Therefore, I get 2x divided by 2 greater than 10 divided by 2. You can cancel down these 2. Here 1 and here 5. Then we get x greater than 5. That's the answer. X greater than 5 is the answer. So we'll now see here how many steps we have used. 1, 2, 3, 4, 5. After the sixth step, use the answer. The same steps, people, we can write like this. The same thing. 3x minus 3 greater than x plus 1. Yeah. I can take this step very easily. How? People bring this x to this side. Here, plus sign, no. Once it comes this side, remember the sign changes. What happens? 3x minus 3 minus x equals 7. Here 3x minus x is 2x minus 3 coming, no? This is coming very easily. Meantime, take this minus 3 to right hand side. If you take both at once, x to left hand side and minus 3 to right hand side, then you can very easily take this step. Then that is the shortcut. Take this x to this side, take this minus 3 to right hand side. This is 2x, this is 10. See here, this one we got directly. So therefore, here in after people, this way we use. Very easy. That means the same theorems we apply at once. Okay. Then divide by 2. Then we get x greater than 5. The same answer comes. This answer x greater than 5 people, we mark on the number line like this. Here number line we have 5. X greater than sign. Sometimes people we may have x greater than or equal to 5. Here we have greater than equal. So now this contains two signs. If we take only this upper one, it is greater than. This line and this line together when we consider that is equal sign. So therefore this is called as greater than or equal. Here we don't have equal. This says x greater than 5. On the number line, this x greater than 5 we mark like this. First at 5 we circle. And the circle we don't color. If we color this one, that says x equal 5. And we circle and don't color. Don't color means we don't take that 5. Without taking 5, all the rest values. Then we color the rest part like this. Therefore, on the number line, this is how we mark this x greater than 5 interval. How? Since here we don't have equal sign, we circle at 5, but don't color the circle. If you color circle, it says x takes 5 and the rest more values. Since here we don't have equal sign, don't color it. This is the first way of representing this. Another way we have people to represent this. Right. So now this way, x greater than 5 means all the values which are greater than 5, this x can take in this inequality. Up to what? Infinity. So therefore, we write this in another way. It is this. Here, x doesn't take 5. And this way, going to write x doesn't take infinity. Nobody can go to infinity on the number line. Right? Nobody can take infinity. Nobody can reach the infinity. If it is possible to reach the infinity, definitely that infinity should be on the number line. We said that infinity is not on the number line. So therefore, the first way of writing is this. We write this way, normal parenthesis. Right? This normal parenthesis we use people to say, we write here 5. And infinity. This way, 5 comma infinity. This normal parenthesis says people, they say this 5 and infinity both not included. They are called as people open interval. Then we write x belongs to this 5 infinity. That means this normal parenthesis is called open. Open means people, this x doesn't take 5 and this x doesn't take infinity. 5 infinity is that. Okay. Right? This is how we write this result in two ways, another two ways. This is called as open interval. Open interval. Right? Normal parenthesis we use to say this values not included into our region. Then to satisfy this inequality, x can take any real number on the number line which are greater than 5. Put any value for x here and here from this region, greater than 5 region, like 10, put here, 3 into 10, 30 minus 3, 27. Here, 10 plus 7, 70, 23 greater than 70, 70, true, no? This is how people we write the regions, right? Write down that too. Open interval, right? I will take the next one. Next one, people, number 2. X plus 8 greater than or equal to 5x plus 12. This tutorial, inequality tutorial, already posted only for some students. Right? The people who made the payments, of course, posted the tutorial. Right? I think they will reach. They will get the tutorial by not tomorrow, by Monday or Tuesday. Okay. Others, please. No, I am not, of course, participate into these works, postages and all. The other people, they work here. They do this thing. They follow the payments and then only the postage is done. So therefore, if you put the payments, then quickly put your flip to the WhatsApp number to get the tutorial, right? Right. We'll count this. We take this 5x to this left-hand side. That will be minus. We will minus 8. Take this fine. Here, minus 4x. Here, we will 4. Now to find this x, we have to eliminate this minus 4 now. Divide by minus 4. When you divide both sides by minus 4, people, we know the direction of the integral sign gets opposite and other way, right? And then what do you get? Minus 4x divided by minus 4. Now this greater than equal will be less than equal. 4 divided by minus 4. In minus you can cancel down. 4 you can cancel down. X less than or equal to, this is plus minus minus. Now we have x less than or equal to minus 1. X less than or equal to minus 1. This time we have less than or equal to minus 1. On the number line, if I mark minus 1 here, less than or equal sign also there. Then we have circle here. Circle and color. And the rest ones here. Right. This is first way. Second way, x belongs to, now this way, x can take negative infinity. X can go to negative infinity, but x never reaches the negative infinity. Nobody can go to people negative infinity. Then here it is written like this: negative infinity, comma, minus 1. Now this time, minus 1 included. Then there we have to put square bracket like this. This is known as people closed. This is open. Then this is open closed. This square bracket says this figure near to the square bracket is included into our region. Right? This is called as open closed interval. Open closed interval. Open closed interval. Right? Open closed interval is this. Right now? Yeah. Okay, now we'll come to some more questions. People, you want a break? Like 10 minutes break? Okay, right. Now, next question is this. Right. Suppose people we have this way an inequality to find the answer. X minus 2, x plus 2, then no equal 0. Comes to this question. We have on the left hand side product of two factors. Product of two factors. Definitely, we should have this way factors. Otherwise, directly we can't find the region. When we have factors like this, I'll tell you how to take the region. Okay. First, each factor, x minus 1 and this x plus 2 equal to 0. This each factor we have to equate to 0. Right? Then find x value. How? Take this to right hand side. X is 0 plus 1, x is 1. Here, x is 0 minus 2, 0 minus 2 is minus 2. Right? Now, these found x values, we have to mark on the number line. Right? X minus 2 is here. Plus 1 is here. Right. Now, here we have equal sign. This sign means, this means there are two signs in it. One is this less than sign. Other one, this and this together equal sign. This is called as less than or equal to. Since here we have equal sign, both these marked values we have to take. Both this marked value you have to take. The reason is, when we put 1 for x here and here, what happens? Here 1 minus 1, this bracket is 0. And 1 plus 2, bracket is 3. 0 into 3 product is equal to 0. Okay? This equal sign become valid when I put x equals 1. Similarly, minus 2 when you put, the same thing happens. That is why we say, if we have this equal sign here, that marked values we have to include. Include means people circle and color the circles. Okay, right. Now you can very clearly understand, after marking this way, these two numbers on the number line, there are three regions on the number line. The region on the left of minus 2. The region between minus 2 and 1. The region greater than 1. Now what we do is this. Consider any region you like. Consider any region you like. Then from that region, take any number you like. That number we substitute for this x and we simplify the left hand side. And we check whether the answer we got suits with this less than or equal to 0 sign. Right. Now I am going to take a value in this interval from minus 3 to 1. What is the value? EC's value is 0. Any value you can take from that region, but we take the EC's value, right? Once I take 0, let x equals 0. That 0 is in this interval. I put 0 here. 0 minus 1. 0 plus 2. Right. What is here? This is minus 1. This is 2. Then here we have sign less than 0, less than or 0. Here we get minus 2, less than or 0. Now we have to check whether this is true. People really minus 2 less than 0. That's true, no people. Not for this equal sign. Minus 2 equals 0 is not true. But minus 2 less than 0 is true. One sign, here we said there are two signs, no? Less than or equal to. If one sign match, truth, then we accept that. This is true. Minus 2 less than 0, true. Then people, like this 0 in this interval, other numbers in this interval satisfy this inequality. Therefore, we mark that like this. Okay. If you mark like this, people, definitely, if this satisfies true, definitely the next adjacent ones regions, that means the region on the left of minus 2 and the right of 1, definitely they never satisfy. If necessary, you can verify that. How? This way, taking a value. Let I take a value in this interval, x is 2. Put that 2 where here? 2 minus 1. Right. And 2 plus 2. The less than equal to 0. Here 1, here 4. Less than equal to 0. 4 less than or equal to 0. This is true, people. 4 less than 0. Oh, 4 equals 0. True. No, not true. False. I like that if you substitute any other value for x from this region, this is the false result get. Therefore, this region we don't take. And we'll take another one here in this interval on the left of minus 2, like minus 4. What do you get? First bracket, minus 4, minus 1. Minus 4 plus 2. Less than or equal to 0. Here what we get? Minus 5. Here, minus 2. Less than or equal to 0. What is this? Minus 5 minus 2 product is plus 10. Less than or equal to 0. Is it true? 10 less than 0? No, false. False. Right? So therefore, this region also does not satisfy this. That is why, people, I told you, if you find one region that can be satisfying or not satisfying, if that is satisfying, then definitely the adjacent ones do not satisfy. Now, suppose in this question, this middle region does not satisfy, then definitely other two adjacent ones definitely satisfy. One after other, satisfy not occurs. So therefore, you have to find out one region, whether that satisfies or not the given inequality. Accordingly, you can determine the rest. No need to put this way the values from each region. Always we select the region in which that 0 contains, because when you put 0 for x, we can very easily simplify. Right? Then, as the first question, these people, you have to do this. But in the latter questions, we never do like this, selecting a value from each region. We select only one region, a value from that region, and we put in the inequality and check whether it is true or false. If it is true, we accept. If not, we reject that one. Accordingly, we take. Okay? All right. So therefore, this is the region. Then how to write this region, people? This region is obtained, therefore, this way. Right? First, what people? X here less than or equal to 1, greater than or equal to minus 2. Second way, x belongs to both 1 and minus 2. Take no, x belongs to the closed interval minus 2 comma 1. This will be right. Right. I think you could understand this. Up to you could understand. Okay. But people, in your term test in schools, usually, they expect something different from this. But in oral examination, that is not anyway important. In term test, in some provisions only, this is required. They expect particular table for this. For the table, 5 marks or 10 marks given. Then the table can be prepared like this. This is how we prepare the table. Right. This range, when we see people, there are three regions now. Less than -2, between -2 and 1, greater than 1. Right. First region is on the left of -2. On the left of -2 means any number on the left of -2 smaller than -2. Then we write it is x less than -2. X means any real number on this region. When that x lies on the left of -2, that x is less than -2. No, that is why I wrote here. And here, between -2 and 1, it is between how? X greater than -2, less than 1. Right? Less than 1. Next one, x greater than 1. X greater than 1. Okay. This way we prepare the table. Or if you write it like this, also correct, people. No? Put 1 here. X greater than 1. That's also correct. Now, in this interval, what is the sign you got? When you put x equals -4, we get people what? Positive answer we got, no? 10, no? Positive answer we got. Then we put here plus. In this interval, we get negative answer. We put minus. In this interval also, we got positive. This is a table they need. This table they need. But asking people what negative, no? Negative we got here. That is why we select this region. So therefore, in addition to these people, you have to put this table there. Then what you need to do is this. Don't take these three numbers. Right? Select n region and any number you like. Mostly we select what? The 0. That region only we select. Put 0 and find whether it is true or false. If true, take this. Don't substitute this way the other numbers. Now prepare the table. That true one, put the sign here. Then interchange the sign on the either sides. Then complete the table suddenly. That's all. Then finally we have the region like this. This way. That's all. Okay, right. That's how we take the answer. Okay, people. So therefore, in the next question, when I work out, people, I am not going to show this all. And I'm not going to show this table. Pointless. But when you answer questions in the term test, put this table there. For this 5 marks or 10 marks you get, but oral examination for the preparation of the tables, marks won't come. Because there are many things to do there to pick marks. Right? Yeah. Okay. So this is how we take the answer. Now we'll take another one more. Next one is this. X minus 1, x plus 2, x minus 4 greater than or equal to 0. Find the range. Find the range. Right, people? Okay. Now, first thing I told you, equate this each bracket to 0 and find x value. If we don't have x coefficient, if the x coefficient is +1, those x values we can very easily find. Huh? Change this sign to opposite. Like this. If coefficient of x is positive 1 in each bracket, to find that x values which we get by equating each factor to 0 can easily be obtained changing the sign of this number to opposite. Okay. Otherwise, we have to equate this each bracket to 0 and we have to find x value. Those x values only we have to mark. Soon after finding this way the x values, people, draw the number line. Draw the number line. On the number line, we have to mark these numbers. X is 1, x is 4. I take 4 here, 1 here, minus 2 here. Right. Now, how many regions people we get? 1, 2, 3, 4 regions now we get. Because we marked 3 numbers now. Right. Now, equal sign available here. Then all these numbers we take, circle and color. This way, circle and color. Right. Now we have to take a region. Any region we like, we can take. But what region we select, people? The region where the 0 lies. Why? Simplification is easier. What region the 0 lies? This interval. Minus 2. Here, this is 1. No? In between minus 2 and 1, not 0 lies. That 0 we put where? For every x in this bracket. So what do you get? 0 minus 1. 0 plus 2. 0 minus 4. Greater than or equal to 0. Now simplify this. This is minus 1. This is 2. This is minus 4. Greater than or equal to 0. Minus minus plus. 1 into 2 into 4 is 8. 8 coming as this product. Greater than or equal to 0. Is this true, people? Yeah, it is true. Then this region we have to accept. Then what is the rule? If this accept, the next one we reject. The next one we accept. Now, if this accept, this one is reject. Then we get 2 regions. Right? Now, when you prepare as a requirement in your school term test, here itself, prepare a table like this. What are the values we put there? This interval x less than minus 2. What is this interval? X greater than minus 2, 1. Here, this 2. Here, it's very easy to write. These 2 values we write, and in the middle we write x. Write in this way the sign. This 2 we write here and here. In the middle we write x. Write in the signs like this. Here we write this 4. Again this less than sign x. Right. Because this one we accepted because the answer had the positive sign. This is positive. This we reject because negative, no? This we accept because positive. This we reject because negative. Put this way the signs. That's all. Then the requirement of the term test. Now you fill. Now finally write the people answer. There are two regions here, this and this. Then how to write? First one, x less than or equal to 1 here, greater than or equal to -2. Oh, what next? X greater than or equal to 4. This first way. Second way, what people? X belongs to this interval. Close the interval. Then put the square bracket like this, -2, 1. What is this interval? Square bracket 4 up to infinity. But infinity nobody can take. Then we have to put normal bracket like this, normal parenthesis. Then x belongs to this interval or this interval. You know, people, in your oil, when we write A, O, B, what is the notation you used? Union, no? That union we put here. This means what? X belongs to this interval or this interval. This is having the meaning O. Then we put here double brackets like this. This is how we write the set of solution. Okay. In the middle we have put O. Okay. Next one, we'll take another one more. That is, find the range of x of x squared minus 6 less than or equal to 6. X squared minus 6 less than or equal to 6. This is the question now. People, can we straight away find the range? No. Why? We said, people, on the right hand side we should have 0 like this, and the left hand side we should have factor. Otherwise you can't find range. So our first step is what? Bring this 6 to this side. That will be -6. Less than no, equal to now. Once you take the 6 to this side, this is 0. Right hand side 0. Then we get quadratic expression in the left hand side. Like this. Okay. Now this quadratic expression, factorize this, obtain 2 factors and do the rest. Here, people, you have to factorize this. What are the factors here? The 2 factors going to be, people, this way. Right? X minus 3, x plus 2. Factorization of this kind of quadratic expression, I think you can do. Okay. Now, draw the number line. Change the signs. Here 3, here -2. Equal sign available. Take both. 0 lies in this interval. It is not compulsory to substitute 0 always. Any number you can take. Definitely, if this one of this value marked on the number line is 0, no longer we can take 0 to substitution purpose. Understood? That occasion, definitely we have to select a value other than 0. But we use 0 for convenience of simplification. Right? 0 is in this interval. Put 0 here. What do you get? First bracket 0 minus 3. First bracket minus 3. 0 plus 2. Second bracket plus 2. Here we put this way. Left hand side minus 3 into 2 minus 6. Less than 0. Is this true? Yeah, this is true, people. Then we accept this. Then this 2 we reject. Now, if you need that table, you can prepare the table. In this case, what the table? For table, people, this way. Right, how to write that? Minus 2, 3. Put this way. And 3 next here. Put this way. And minus 2, x minus 2 this. These numbers on either side of this vertical line we equal here. Minus 2, minus 2, 3, 3. And the signs also arrange in the same direction. No? Then very easily you can prepare the table. These values minus 2 come in on the left of this line, right of this line. These 3 come in left of this line, right of this line. And the direction here is there everywhere. Here in the first and last we put x on the right, others x in the middle. Very easy. This we got middle one minus, then other we get plus. Then prepared the table 2. Now we got the answer. So what is the answer? Right, then I am going to write the answer here. Right, therefore x less than or equal to 3, greater than or equal to minus 2. That is first way of writing. No need to write in both ways. I wrote that one to understand this way of writing the second method. Then second way, what, people? X belongs to both should be what? Square bracket minus 2 comma 3. This is how we take it down. Okay. And then people next day we continue the lesson from here. Right. I think the tutorials, of course, posted today. Then those tutorials tomorrow or Monday. By Tuesday evening, definitely you will get the tutorial. Right. Okay. So then, people, we meet the next class next Friday. Next Friday, we are supposed to finish part 50% of this lesson and supposed to come to as soon as possible of this lesson to start the next one lesson, linear motion and velocity time graph lesson. Right. Okay. Any question for you today regarding to the lesson?